Let's have a drill. Number 1. Find the first term of the sequence whose general term is a sub n equals 5n plus 11. 2. Find the seventh term of the sequence a sub n equals n plus 3 over n plus 5. 3. Find the fifth term of the sequence a sub n equals negative 1 raised to n times the quantity n plus 3. Number 4. Find the fourth term of the sequence a sub n equals n minus 1 all over n plus 2. And number 5, find the eighth term of the sequence a sub n equals negative 1 raised to n all over 2n minus 5. Now let's continue our discussion on arithmetic sequence and series. For this lesson's objectives, we have 1. Define the following terms: finite and infinite sequence, common difference, arithmetic sequence, and arithmetic mean. 2. Tell whether a given sequence is arithmetic or not. 3. Determine the common difference and the next term of an arithmetic sequence. 4. Find arithmetic means between terms of an arithmetic sequence and solve problems involving arithmetic sequence. Now ponder on this saying: the man who moves a mountain begins by carrying away small stones. Now this saying by Confucius relates well to our topic, arithmetic sequence, and you'll see why. Now let's take a look at this problem. Cardo is a very athletic person. He usually joins fun runs and marathons. Unfortunately, he got injured in one of his events when his ankle got twisted. He was told to take some rest and was advised to return to his jogging program slowly. In the program, he needs to jog for 15 minutes each day for the first week, then an increase of 7 minutes per day on the succeeding weeks. That is 22 minutes each day of the second week, 29 on each day of the third week, etc. How many minutes does Cardo have to jog on the 10th week of the program? Now, this and more are the types of problems that can be solved using our knowledge of arithmetic sequence. Now, if you try solving this, you'll arrive at the answer 78 minutes. Now, what is an arithmetic sequence? An arithmetic sequence is a sequence where every term after the first is obtained by adding a constant called the common difference. An arithmetic sequence is a sequence in which the difference between any two consecutive terms is the same. Now, an arithmetic sequence can either be finite or infinite. If there's a last term, then that arithmetic sequence is finite. Otherwise, it is infinite. The three dots called ellipses indicate that the sequence is infinite. Now just take note that it is an arithmetic sequence if there exists a common difference between all consecutive terms in the sequence. Now to illustrate, 2, 5, 8, 11, 14 is a finite arithmetic sequence. 2 here is the first term denoted by a sub 1. 5 is the second term denoted by a sub 2. 8 is the third term denoted by a sub 3. 11 is the fourth term denoted by a sub 4. And 14 is the fifth term denoted by a sub 5. But since it is the last term, then it is also denoted by a sub n. Now, what is this common difference? The constant difference is called the common difference and will be denoted by D, by the letter D. Now, to find the common difference D in an arithmetic sequence, just subtract the first term from the second term, or the second term from the third term, or simply subtract two succeeding terms. Now, in notation, we'll have D equals second term minus the first term, or D equals third term minus the second term. Now let's have examples. Find the common difference of the following arithmetic sequence. Number 1, you have 21, 31, 41, 51, and 61. Now the common difference D here will be equal to 31, the second term, minus 21, the first term. So D here, the common difference is equal to 10. Or you can also have the third term, which is 41, minus the second term, which is 31. And that will also give you a value of 10. Now, how about this? So here, D is equal to negative 4. How about this? So here, D is equal to 2/3 minus 1/3. That is equal to 1/3. Now take note that to get D, it's the term on the right minus the term on the left. Now let's go to the general or the nth term of an arithmetic sequence. Now recall, the general term is also the nth term, which is denoted by a sub n. Recall also that the general term is also called the formula, and the general term is also called the equation. Now notice this. If a sub 1 and D are known or given, then we can use this equation. A sub 2 equals A sub 1 plus D, meaning the second term will be equal to the first term plus the common difference. A sub 3, the third term, will be equal to A sub 2, which is the second term, plus the common difference. A sub 4 will be equal to A sub 3 plus D. A sub 5 is equal to A sub 4 plus D. A sub 6 is equal to a sub 5 plus d. Thus, the general term of a sequence can be written using a recursive formula, which is, right. So the general or the nth term of an arithmetic sequence, okay. So here is the general rule for arithmetic sequence. So we have the formula a sub n equals a sub 1 plus the quantity n minus 1 times d, where a sub 1 here is the first term, n is the number of terms, d is the common difference, and a sub n is the last term. Now notice again that a sub 2 is equal to a sub 1 plus d. A sub 3 is equal to a sub 2 plus d. But a sub 2 is equal to a sub 1 plus d. Thus, a sub 3 will be equal to a sub 1 plus d plus d. Now, this a sub 1 plus d here, remember, this is just our a sub 2. Therefore, a sub 3 can be written or can be expressed as a sub 1 plus 2d. Now, notice again that a sub 4 is equal to a sub 3 plus d. But a sub 3 is equal to a sub 1 plus 2d. Thus, a sub 4 will be equal to a sub 1 plus 2d plus d. This expression here in blue is our a sub 3. Therefore, a sub 4 will just be equal to a sub 1 plus 3d. Now notice more that a sub 5 is equal to a sub 4 plus d, but a sub 4 is equal to a sub 1 plus 3d. Thus, a sub 5 is equal to a sub 1 plus 3d plus d. Therefore, a sub 5 can be written as a sub 1 plus 4d. Now, notice more that a sub 6 is equal to a sub 5 plus d, but a sub 5 is equal to a sub 1 plus 4d from the previous slide. Thus, a sub 6 will be equal to a sub 1 plus 4d plus d. Therefore, a sub 6 will be equal to a sub 1 plus 5d. I hope you're getting the pattern. Now, to summarize, if a sub 1, the first term, and d, the common difference, are known or given, then a sub 2 will be equal to a sub 1 plus d. A sub 3 will be equal to a sub 1 plus 2d. A sub 4 will be equal to a sub 1 plus 3d. A sub 5 will be equal to a sub 1 plus 4d. A sub 6 will be equal to a sub 1 plus 5d. Now, using inductive reasoning, what is a sub 20? What is a sub 75? What is a sub 100? So for the answers, a sub 20 is equal to a sub 1 plus 19d. A sub 75 is equal to a sub 1 plus 74d. A sub 100 is equal to a sub 1 plus 99d. Now let's have this example. Determine the next three terms of the sequence 6, 12, 18, 24, 30, and 36. Now, to solve this problem using the general rule or formula for arithmetic sequence, we'll have, so for the first step, find the common difference d. So d here will be equal to 12 minus 6, that is 6. Now for the second step, find a sub 7, meaning the seventh term, by replacing n by 7 and a sub 1 by 6. Now this is the formula for arithmetic sequence. So replace n by 7. So we have a sub 7 equals a sub 1, replace that by 6. So you have 6 here, plus the quantity n is 7. So 7 minus 1 times 6. So we'll have a sub 7 equals 6 plus 6 times 6. That will be 42. Next, find a sub 8 by replacing n by 8 and a sub 1 plus by 6. So again, using the formula for arithmetic sequence, so a sub n will now be a sub 8 equals a sub 1 is 6. So 6 plus the quantity n is 8. So the quantity 8 minus 1 times d. But d is just 6, so replace d by 6. So we'll have a sub 8 equals 6 plus 7 times 6, and that will give us a value of 48. Now to find the ninth term, or a sub 9, so using again the formula for arithmetic sequence, substitute 9 into n and 6 into a sub 1, we'll have a sub 9 equals 6 plus the quantity n minus 1 times 6. So we'll have a sub 9 equals 6 plus 8 times 6, which is 54. So the next three terms of the sequence are 42, 48, and 54. So notice, seventh term is 42. You add the common difference, which is 6, you get 48. Add 6 again, you get 54. Alright. Hence, the next three terms of the arithmetic sequence are 42, 48, and 54. Now, we can use another method to solve this problem. So, using another method, we have a sub 7 is equal to a sub 1 plus 6d. Replacing d by 6, we have this. And solving, we will get a sub 7 equals 42. To get the eighth term, we have a sub 8 equals a sub 1 plus 7d. Replacing d by 6, we get this. And therefore, a sub 8 or the eighth term is equal to 48. Now to solve for the ninth term, we can use the formula a sub 9 equals a sub 1 plus 8d. By substitution, we get this. By solving, we have a sub 9 equals 54. Now let's have another example. Find the seventh term of an arithmetic sequence if the third term is 5 and the fifth term is 11. So here, we're given that the third term is 5. And we can use the formula a sub 3 equals a sub 1 plus 2d. Now by substitution, so replace a sub 3 by 5, we have 5 equals a sub 1 plus 2d. Since the third term is 5, meaning a sub 3 is 5, so replace a sub 3 here by 5. Now let's call this equation 1. Next, we're also given the fifth term. So the fifth term here is 11. And so we can use this formula, a sub 5 equals a sub 1 plus 4d. Replacing a sub 5 by 11, we have this equation. 11 equals a sub 1 plus 4d. And let's call this equation number 2. So here we have two equations. Next is form a system of equations using equation 1 and equation 2 and solve for d. Then eliminate the variable a sub 1. So let's form a system of equations using equations 1 and 2. So we have 5 equals a sub 1 plus 2d. This is equation 1. And we have 11 equals a sub 1 plus 4d. This is our equation 2. So to eliminate a sub 1, we need to subtract equation 2 from equation 1. So subtracting, we have negative 6 equals negative 2d. Dividing both sides by negative 2, we get d equals 3. So now we have the common difference. Next step is we solve for a sub 1 or the first term using equation 1. So equation 1 is this equation, 5 equals a sub 1 plus 2d. So replace or substitute 3 into d. We have 5 equals a sub 1 plus 2 times 3, since we were able to solve for the value of d, which is 3. Therefore, 5 is equal to a sub 1 plus 6. Transposing this 6 to the other side, to the left side of the equation, we will get a sub 1 equals negative 1. Now finally, we can now solve for the seventh term. And we can use this formula, a sub 7 equals a sub 1 plus 6d. Now notice that we have the value for d and a sub 1 already. So substitute those values. We have a sub 7 equals negative 1 plus 6 times 3. So that will give us 17. So therefore, the seventh term of this arithmetic sequence is 17. Now let's have another example. If the fourth term of an arithmetic sequence is 24 and the 12th term is 56, what is the first term? So here we are given the fourth term, which is 24. So therefore, we can use the formula a sub 4 equals a sub 1 plus 3d. Since a sub 4 is given, so replace a sub 4 by 24. So we have 24 equals a sub 1 plus 3d. And let this be our equation number 1. Next, we're also given the 12th term. So the 12th term here is 56. Therefore, we can use this formula a sub 12 equals a sub 1 plus 11d. Replacing a sub 12 by 56, we get 56 equals a sub 1 plus 11d. Now let this be our equation number 2. So next step is we will now form a system of equations using equations 1 and 2 and solve for d. Eliminate the variable a sub 1. So this is our equation 1, remember? And this is our equation 2. Now to eliminate a sub 1, we will subtract equation 2 from equation 1. So we will get negative 32 equals negative 8d. Now dividing both sides by negative 8, we will have d equals 4. Now let us solve for a sub 1 or the first term using equation 1. So if we use equation 1, we have 24 equals a sub 1 plus 3d. Replace d by 4 since we are able to solve for d now. So you have 24 equals a sub 1 plus 3 times 4. So a sub 1 will be equal to 24 minus 12, and that will be equal to 12. So the first term here is 12. Now in the previous problem, in example number 2, can it be possible to solve for a sub 7 without solving for a sub 1 and d? The answer is yes. But how? We can solve it by using this formula. So looking at another perspective, we can use this formula. A sub n equals a sub m plus the quantity n minus m d, where n and m here are natural numbers. Now take note that n minus m can either be positive or negative. So we can use this formula if a sub 1 is not given. Then if we use that formula, then any term may be solved given any two other terms. Okay. Now to illustrate, let's have this example. Find the 30th term of a sequence if its 10th term is 67 and its 17th term is 116. Now notice that here we're not given the first term. Okay. But what are we given here? We're given the 10th term, which is 67. So we can denote that as a sub 10 equals 67. And we also have a sub 17. So we can use this formula. A sub 17 is equal to a sub 10 plus 7d. But a sub 17 is 116, therefore by substitution, we get 116 is equal to A sub 10 is 67, therefore we have 67 plus 7D. Transposing 67 to the left side, we have 49 equals 7D. Dividing both sides by 7, we get D equals 7. Now we're also given the 30th term here. So we can also use this formula. A sub 30 will be equal to A sub 10 plus 20D. Where did we get this 20? Remember, this is from 30 minus 10. Therefore, A sub 30 will be equal to 67 plus 20 times 7, which will give us this. So A sub 30 will be equal to 207. Therefore, the 30th term is 207. Now, answer activity 1.7 titled Identify and Solve Me on page 15, and activity 1.8 Do You Miss Me on pages 16 to 17 of your learning package 2. Now let's go to the next topic, arithmetic mean. So for this topic, we will define and illustrate arithmetic means and find arithmetic means between terms of an arithmetic sequence. Now recall, find the average. So give me the average of 76 and 80. Number 2, give me the average of 24, 27, and 30. Now, what are these arithmetic means? So, the terms of an arithmetic sequence that are between two given terms are called arithmetic means. So, an arithmetic mean is also the average between two terms in a sequence. So, because it's mean, therefore it's an average. Now, let's have an example. What is the missing term in the arithmetic sequence 15 blank 27? So here, the second term is missing, and that second term will be denoted by A sub 2. So again, this arithmetic sequence is of the form 15, A sub 2, 27. Now this means that A sub 1, the first term, is equal to 15. A sub 3, the last term, is equal to 27. And n is equal to 3 because there are 3 terms here in this sequence. Now, how do we find the common difference, or D? So we use the formula for arithmetic sequence, this formula, and then substitute the given. Our A sub n here is also our A sub 3, which is 27. A sub 1 is 15, and here is 3. Now we're looking for D, so D is still D. So we have 27 equals 15 plus 2D. So 2D is equal to 12. Dividing both sides by 2, we get D equals 6. Now we have the common difference. So to solve for the arithmetic mean, we will have the arithmetic mean here is A sub 2. So a sub 2 will just be equal to a sub 1, which is 15, plus the common difference, which is 6. So therefore, the arithmetic mean here is 21. Now let's have another solution for this problem. So another solution could be just to get the average of 15 and 27. Remember, arithmetic mean is an average. Thus, arithmetic mean here will be equal to 15 plus 27, the first and the last term, all over 2. And that is just 42 over 2, which is 21. So therefore, the arithmetic mean is 21. Now, what if we're asked to find not just one, but say three arithmetic means? For example, determine three arithmetic means between 17 and 11. So this arithmetic sequence is of the form 17, a sub 2, a sub 3, a sub 4, and 1. So these three here, a sub 2, a sub 3, and a sub 4, are the three arithmetic means between 17 and 1. Now this means that a sub 1 is 17, a sub 5 is 1, a sub 5 here is also our a sub n, and n is equal to 5 since there are 5 terms here. Now to find the common difference, d, again we use the formula for arithmetic sequence and then substitute the given. We'll have 1 equals 17 plus the quantity 5 minus 1 times d. So 1 is equal to 17 plus 4d. Transpose 17 to the left or 4d to the left. It's just the same. So negative 4d equals 16. Divide negative 4 on both sides. So d will be equal to negative 4. So solving for the arithmetic means, again, we use the formula for arithmetic sequence. This formula. So to solve for a sub 2, we have a sub 2 is equal to a sub 1, that is 17, plus negative 4. Since n here will be 2, so 2 minus 1, that is just 1. D is negative 4, so 1 times negative 4 is just negative 4. Therefore, a sub 2 is 13. Now, to solve for a sub 3, then you just simply add negative 4 to a sub 2. So, a sub 3 is equal to a sub 2 plus the common difference. That's why it's 13 plus negative 4 equals 9. So, to solve for a sub 4, just get this, the third term, which is 9, and then add the common difference, which is negative 4. So, you get 5. Therefore, the arithmetic means are 13, 9, and 5. You may now answer activity 1.9. Can you insert my means on page 18 of your learning package 2 and activity 1.14 on pages 24 to 25 of your learning package 2. Now let us go to the next topic, arithmetic series. So for this topic, we will determine the sum of the first n terms of a given arithmetic sequence and solve problems involving arithmetic sequence and series. Now, what is an arithmetic series? The sum of the terms of an arithmetic sequence forms an arithmetic series. So if you add up the terms of your arithmetic sequence, then you have your arithmetic series. Now, to find the sum of an arithmetic sequence, we can use this formula. S sub n equals n over 2 times the quantity a sub 1 plus a sub n. We will use this formula if a sub n or the last term is given. Or we can use this second formula. S sub n equals n over 2 times the quantity 2 times a sub 1 plus the quantity n minus 1 times d. Now we use this second formula if a sub n is not given, meaning the last term is not given. Where S sub n here is the sum of the terms of your arithmetic sequence. A sub 1 is the first term of the sequence. N is the number of terms in the sequence. A sub n is the last term of the sequence. And D is the common difference. So take note of these two formulas. So this first one we use if a sub n or the last term is given. This second formula on the right, we use this if a sub n or the last term is not given. So let's have an example. What is the sum of the terms of the arithmetic sequence 24, 29, 34, 39, 44, and so on and so forth up to 74? Since we do not know the number of terms in this sequence, then we need to solve for n, the number of terms first. So solving for n, we have, here we're given the first term, so a sub 1 equals 24. A sub n, the last term, is equal to 74. To solve for d, the common difference, that will be d equals 29 minus 24, or d equals 5. Now, using the formula for arithmetic sequence, we have this. So, substitute the given values. So, here you have a sub n, the last term is 74, a sub 1 is 24, and d is equal to 5. Notice that after substituting the given values, we only have one unknown, which is n. So, evaluating or simplifying, we'll have 50 equals 5 times the quantity n minus 1. Dividing both sides by 5, so that this 5 here on the right will be eliminated, we'll have 10 equals n minus 1, leaving us with n equals 11. So therefore, there are 11 terms in this given sequence. Since we now know the number of terms which is denoted by n, we can now solve for the sum, denoted by s sub n, of the given arithmetic sequence. So solving for s sub 11, so we will use this formula. S sub n equals n over 2 times the quantity a sub 1 plus a sub n. Since we know n, we know a sub 1, and we also know a sub n. So substituting the given values, we have s sub 11 equals 11 over 2 times the quantity 24 plus 74. That will give us S sub 11 equals 11 over 2 times 98, which will give us a value of 539. Therefore, the sum of the 11 terms denoted by this S sub 11, this means sum of the 11 terms in the given sequence is 539. Next example. Find S sub 10, meaning sum of the 10 terms of your arithmetic sequence. So find S sub 10 if A sub 1 equals 5 and A sub 10 equals 68 and B A sub 1 is 5 and D equals negative 7. So let's try letter A first. In letter A, since we are given A sub 1 and A sub n here, then we can use this formula. S sub n equals n over 2 times the quantity A sub 1 plus A sub n. Now by substitution, we will have S sub 10 will be equal to 10 over 2 plus, times the quantity 5 plus 68. Here, your A sub n is 68. So your n here is 10. So S sub 10 will be equal to 5 times 73, giving us a value of 365. Therefore, the sum of the first 10 terms of this arithmetic sequence is 365. Now, in letter B, since we do not know A sub n, then we use this formula. S sub n equals n over 2 times the quantity 2 times A sub 1 plus the quantity n minus 1 times D. So by substitution, we have this. So substitute 10 into n. A sub 1 is 5, n is 10. And D here, we were able to solve it earlier. It's given here. D is negative 7. Therefore, S sub 10 is equal to 5 times the quantity 10 minus 63, and that will give us a value of negative 265. Now, let's have problems involving the application of arithmetic sequence. Now, let's try this problem. On July 1, 2011, Carlo invested 10,000. The investment earns 6% simple interest per year, paid on July 1 of each year. The value of the investment on July 1 on each of the 4 successive years are 10,000, 10,600, 11,200, and 11,800 respectively. What will be the value of the investment on July 1, 2020? So here we are given the first term denoted by A sub 1. So the first term here is 10,000. What else are we given? We're also given the second term. So A sub 2 here is 10,600. What else? N here will be equal to 10 since from 2011 to 2020, that will be 10 years. Okay, so solving for D, we have 10,600 minus 10,000. So D will be equal to 600. Now, to solve for the value of the investment after 10 years, we will use this formula for arithmetic sequence. So our n here is 10, therefore A sub 10 will be equal to 10,000 plus 9 times 600. Since A sub 1 here is 10,000, your n is 10. So 10 minus 1, that will be 9. D is 600. So A sub 10 will be equal to 15,400. This means that The value of the investment on July 1, 2020 will be 15,400. Now, do you remember this tongue twister? Peter Piper picked a peck of pickled peppers. A peck of pickled peppers Peter Piper picked. If Peter Piper picked a peck of pickled peppers, where's the peck of pickled peppers Peter Piper picked? Okay. Now I know you remember this tongue twister. Now let's modify this and then let's have a problem on arithmetic sequence out of this tongue twister. So try this. If Peter Piper picks 4 pecks of pickled peppers on day 1, 7 pecks on day 2, and each day thereafter picks 3 pecks more the previous day, how many pecks will Peter pick on day 12? So let's analyze the given here. So we're given 4 pecks. This will be our A sub 1. So A sub 1 is 4. And then this 7 pecks on day 2 will be our A sub 2 or the second term. This day 12 will be our N. So our N here is 12. So again, we have A sub 1 is 4, A sub 2 is 7, and D, the common difference here is 3. And here is 12. So using the formula for arithmetic sequence, we have this formula. Substituting the given, we have, since n is 12, so you have a sub 12 equals a sub 1 is 4, n is 12, d is 3. So substitute the given values. We will have a sub 12 equals 4 plus 11 times 3, and that will be 37. Therefore, Peter Piper will pick 37 pecks on day 12. Now you may answer the rest of the activities under Unit 1 of your learning package 2.